Hello everyone, welcome to the fourth video of this concurrency playlist, and in this video we are going to cover the topic of isolation level. We are going to study these 4 points: read uncommitted, read committed, repeatable read and serializable. In the previous video we covered the definition of isolation and all the problems we faced in the isolation of dirty read, non-repeatable read and phantom read. So if we cover the point of read uncommitted, so read uncommitted is saying no lock acquired, either shared or exclusive. These locks I explained you in my previous video of DB locking. So read uncommitted, because of read committed we lie into the problem of dirty read, non-repeatable read and phantom read. These things I explained you in my last example. In my last video I told you about it. So all the three examples that I told you are the prior example of read uncommitted. So if someone asks you in an interview, you can just tell them read uncommitted. All the examples that I told you in my previous video, these are the examples of read uncommitted only, because we are not taking any locks, and in the previous video I didn't make you understand anything related to locks. Now let's see read committed. So read committed, it's saying we are going to take a share lock at the time we are going to read the data, and what we are going to do, whenever our reading is complete we are going to release that lock. But when we are writing a data into a database, at that time we will take a complete lock for the whole transaction. What is going to happen if we take a write lock? It will going to sustain for the whole transaction so that no one can change the data. So this is what read committed is. So it solves the problem of dirty read and not able to solve the problem of non-repeatable read and phantom read. So let's see this thing, how it is doing it. So I draw one example for you. So there are two transactions, T1 and T2 are happening at the same time. So T2 started in writing a transaction. So what happened? T2 is changing the value from P10 to P20 and taken an exclusive lock. So what we have studied in our DB locking, that whenever is T2 updating a data, no one can take a shared lock. So can T1 take a shared lock? Can T1 read the data? Can T1 can read that particular row P equals to 10 or P equals to 20? Then answer is no. T1 cannot even take a shared lock whenever someone is writing a data on that particular row, because T2 is having an exclusive lock on that particular row. So there is never going to be a problem of dirty read. But there is a problem of non-repeatable read in this scenario. Let me make you understand it. So what our read committed says, that whenever you take a shared lock, it is going to be released. So what is going to happen, we read our data P equals to 10, we take a shared lock and we are going to release it as soon as we have read the data. That is what read committed is saying. We have read the data and we release the lock. Now at the same time our exclusive lock is taken by the T2 on that same row, that is x1. Take a read lock on that particular row. Now what will happen? Change the value from P equals to 10 to P equals to 20. And if that value has changed now, what will happen? If value has changed, and if again T1 make a read call to that particular row, what will happen? It will read the data P equals to 20. That was a problem of non-repeatable read, that in the same transaction we should get a same value of the rows, but we are getting a different value. Hence this read committed is not going to solve the problem of non-repeatable read. Now let's understand why read committed cannot solve the problem of phantom read as well. So in phantom read we have studied, we are going to use a range query. So suppose I run again the same query, id greater than equals to 0 and id less than equals to 6. So we are getting two rows, P equals to 10 and S equals to 10. And now this time what will happen? After reading the data, we are going to release this lock. We release this lock, and in this range, what was the range? 0 to 6. In this range someone inserted any value. So let me just take, like someone inserted a value like a fifth row. So what happened? Like someone inserted this S equals to 10. When this insertion will happen, what will happen? If we are again going to run the query, so again T1 is going to run the query id greater than 0 and id less than 6. If this query is going to be run again, what will happen? T1 will get the 3 rows. Previously it was getting 2 rows and now it was getting 3 rows. That was a phantom read problem. Phantom read problem, what was phantom read problem was saying, n number of rows we should get every time we make a read call in the same transaction, but we are getting n plus 1 rows this time. So this is the problem of phantom read that not get solved by the read committed. So now let's understand the third point, that is repeatable read. So repeatable read says that we are going to acquire a shared log for the whole transaction, and we are going to take an exclusive log also for the whole transaction. So it's previously what was like, we are going to take a shared log, but as soon as we are reading it, we are going to release it. But this time we are going to share log also for the whole transaction and write log also for the whole transaction. And now it is solving the problem of dirty read and non-repeatable read. But again, it is not able to solve the problem of phantom read. So let's see it how repeatable read solve all those two problems, but not able to solve phantom read problem. So let's understand it with an example. So I drawn to again a diagram where two transactions are happening, T1 and T2. What happened? First of all, our transaction T1 take a shared log on P equals to 10. So what repeatable read was saying, that if I have taken a shared log, no one can take an exclusive log, no one can update the data. So can T2 perform any action on this particular data? If T2 is not going to perform any write operation on this row, then this row can never change. Hence we will never reach into the property, or hence we will never reach into the problem of dirty read. And n number of times, if T1 makes n number of time read calls to this particular row, so every time T1 will get the same data, p equals to 10, p equals to 10, p equals to 10, because T2 cannot change it. That's what repeated read was saying. If you have a shared log, no one can take an exclusive log on that particular row. So that is why n number of time if you make a read call, then every time you will get the same data, p equals to 10. Hence all the problems are solved of dirty reads and non-repeatable read. Now let's understand the problem of phantom read. Why repeatable read isolation level not able to solve the problem of phantom read? So let's understand it with an example. Again, there is a range query. So what is the range query again? ID greater than 0 and ID less than 6. What happened? We get the two rows. P equals to 10, R equals to 10. So the row number are 1 and 4. We get these two rows between these range. But what can happen right now? This T2 can make entry into a database with the row number 3. This is possible. Because we are not having any log on the row number 3. We are only having the log on 1 and 4 right now. But T2 has changed the row. Now T2 has make a write call on row number 3. What will happen? We have a value s equals to 20 now on row number 3. And again, if we T1 going to run this range query again, ID greater than 0 and ID less than 6, this time what will happen? We are going to get 3 rows. And if we are going to get the 3 rows, we will reach into the problem of phantom read. So what was phantom read saying? If you are having n number of times, if you make a range query, you should get n number of rows, but you are getting some another number. That is what phantom read problem is. Now let's move to the last isolation level, that is serializable. So serializable is saying, I also solve the problem of dirty read and non-repeatable read, and I'm also going to solve the problem of phantom read. So let's understand serializable. Serializable is saying that I'm having all the properties of repeatable read, and I'm having one more property, that is of range log. So let's understand it. So what repeatable read was saying, that I'm having the read log for the whole transaction and the write log also for the whole transaction. So we are not going to cover this how serializable is solving these two problems, because we have just studied it in our repeatable read. So let's see how serializable solve the problem of phantom read. So if we are having again two transaction T1 and T2 in the range query, we again run a range query, that is ID greater than 0 and ID less than 6. What will happen in this time? So if we make a range query, we are getting again two rows, P equals to 10 and R equals to 4. And this is our range 0 to 6. So this time the range log, what the range log will do, it is going to log all the 6 rows 0 to 6. We got only two rows. What are the two rows that we have got? Our row number 1 and row number 4. But our range log is going to log all the 6 rows, because that is our range query 0 to 6. Now if we have a shared log in the row 0 to 6, can T2 insert anything between that particular range log? The answer is no. That is what our range locking is. If you have a shared log on in the range, you cannot make an exclusive log into that particular range. So T2 cannot update it. And if we again make a read call n number of times in that transition T1, what will happen? We are going to get the same number of rows. So this is what serializable is. This is how serializable is solving the range problem also. So we covered all the isolation levels. We have covered all the isolation level problems. Now, in the next video, we are going to cover the optimistic concurrency control and pessimistic concurrency control. So thank you for watching me, and let's meet in our next video, and bye bye.